Hi, this is Colin Monks, and this presentation is the overview of lake ecology models for Pearl Lakes Trout Club. This is a recording of the talk I gave at the members meeting on the 7th, and this is really designed for us to frame our discussion for the management of the lakes of Pearl Lakes. And in the offset, I just wanted to thank my daughter Maya for doing the artwork for this presentation. So this is a diagram of the ideal seasonal life cycle of Pearl Lakes, kind of what we're shooting for. And I'm going to start all these conversations here at spring runoff and go through the cycle of what happens. So in kind of an ideal year, we will get spring runoff with low nutrients in the water. We will have some trout surviving in the lake and clear water. We'll do a spring stocking, and then we'll have lakes full of trout. The nitrogen and phosphorus, the nutrients in the water, will create the growth of rooted aquatic vegetables, and these will make clear water throughout the year's fishing, and we'll have good fishing with habitat for the trout. Then winter will happen, the lakes will freeze, and the cycle will continue. For a good example of this right now, you can look at the way Heart Lake is working, and I think we're also pretty close to having this happening in the Kitty Pond Lakes 1, 2, and 3. So this is a way that this ideal cycle can go off the rails, and I call this type of cycle weed dominant. And we can begin again with spring runoff. This time the water has high nutrient content. And I think this is what we've been experiencing for the past several years, with the exception of this year where we really didn't have much runoff. And this may be due to the fact that our headwaters of Clear Creek now run through a dead lodgepole forest with lots of rotting pine needles and stuff. So basically what happens is you start with clear water, runoff with lots of nitrogen and phosphorus and some fish. We stock again, and then the nitrogen and phosphorus are taken up by rooted aquatic vegetables, much like in the ideal cycle. Only this time there's so much nutrients, you get a huge bloom of rooted aquatic vegetation. What you still have is clear water and happy fish, but what you've lost is the actual area where you can fish, because everything's full of weeds. This is much like Lake 4 used to be 3 and 4 years ago, before we started to attack that lake and kill off all the weeds. What happens in the winter is the lakes freeze, it snows, the lakes get dark, and the plants die. The plants in the dark die, and bacteria in the water eat the plants and deplete the oxygen. And this causes a condition called winter kill-off, where all the fish die over the winter, and you start the spring again with a dead lake. We've seen this historically in 5 and other lakes. Another way that the lake ecology can go off the rails is something I call phytoplankton and blue-green algae dominant. This again begins with spring runoff and high nutrients in the water. Again, you have fish existing. This time we also drew in a sucker. We stock the fish, and this high nutrient content causes a large bloom of phytoplankton and blue-green algae. These are single-celled organisms that photosynthesize, and they will wind up turning the water green when they have a big bloom. The phytoplankton can then be eaten by zooplankton. Those are non photosynthesizing single-celled organisms. And the phytoplankton, dead phytoplankton and zooplankton are both brown. So you could go from a green lake to a brown lake after a few cloudy days to kill these single-celled organisms. And then you have a brown turbid lake. This is making nutrient-rich mud. This makes suckers happy. And then eventually what can happen at the extreme of this is the zooplankton can deplete the oxygen from the lake and kill all the fish. This happened in Lake 7 last year, where there was a large number of dead fish surrounding the outsides of the lake. The suckers in particular got hit by this because they stayed down at the bottom in the mud. Trout, if they are allowed to escape, can escape this condition. But this definitely happened in Lake 7 in 2017. And then the lakes freeze and this cycle continues. There's some clear hallmarks of this. You have clear water in the spring and you have clear water in the fall. You have a cycle of green and brown turbidity in the summer. I believe this is what is predominantly happening in lakes 5 through 8 right now. And then the final way that the lake ecology can go off the rail is a sucker-dominated life cycle. And this is really the only one that was taught to me as a kid. And this is historically what Pearl Lakes had managed in the distant past with cycles of poisoning and draining. So again, we begin with spring runoff. But because there's suckers already in the lake at relative high concentration over the winter, the lakes are already brown at spring runoff. And this brown is due to a kind of lake cloudiness called sediment turbidity. It's basically stirred up mud because the suckers have been running around stirring up mud all the time. Again, we stock fish. We might have a phytoplankton, zooplankton cycle, but we get a lake that is more and more driven by sucker population. It continues to be brown through the through the fall, and then lakes freeze and the cycle continues. So all these ways that the lakes can go off the rails, either sucker dominant or single-celled organism dominant or weed dominant, all happen in a mixture. So in our management of the lakes, it's really in our best interest to figure out which of these is dominating the problems with the lake, and we then make a management strategy based on that. So for suckers, obviously, we have our sucker trapping and abatement program that we are doing. Weeds we control with herbicides, and the cycle of single-cell organisms can either be controlled by, well, really can only be controlled by dropping the amount of nutrients in the water. And so we are attacking this either through a mixture of biofiltering, which is allowing some parts of the lake to have rooted aquatic vegetation to suck up the nitrogen and phosphorus, or we also tried alum treatment in Lake 4, but this really is only effective if you have low nutrient coming into the system, which is not really the case we're in right now. So this is our current status of our lakes as we see it. The Kitty Pond through Lake 3 are well managed with controlled suckers and weeds. Lake 4 was completely drained as part of a sucker experiment to determine if sucker biology is dominating that lake. If sucker biology is dominating that lake, we expect when we restore the lake sucker-free that we will have a decent amount of time with clear water and no turbidity, and if single-celled organisms are dominating that lake, we will quickly return to the cycle of clear, green, brown, clear that we see in other lakes. And lakes 5 through 8 also have phytoplankton and blue-green algae dominating that. So I invite you to write me or call me with any questions or suggestions. As always, we're only trying to come up with the best model for the lake ecology and the best possible management strategy for all our enjoyed fishing. Thank you for your attention.